object-oriented concepts. Now let's see about the programming techniques. A programming techniques is a method of solving a problem based upon certain conditions. This depends on the features of choosing the languages as well as the familiarity of the coding. It can be classified into three different types: procedural programming, structured programming, object-oriented programming. Now, let's see about procedural programming. It's a technique which consists of instructions and how the instructions can be executed step by step. Each program has a starting state which consists of list of operations to be completed and an ending point. This approach is also called as imperative programming. The procedures and functions and subroutines which consist of small programs are together called as functions. This programming is also called as top-down language, in which a program and subprograms are together referred as data or data items. To manipulate a piece of data, the active agent, which is also called as program, issues an action referred to as procedure. Based upon the action, the implementation will be performed in a given task. These procedural languages can be classified into Fortran, which stands for Formula Translation, COBOL, which stands for Common Business Oriented Language, Pascal, C, and Ada. Structured programming. A program will be in the form of structure where all the instructions can be executed one by one. It is also called modular programming, and it is a subset of procedural programming that enforces a logical structure on the program which is written for some particular action, and it can be also modified based upon the conditions. Certain languages such as Ada, Pascal, DBase are designed with features that encourages a logical program. It can be classified into three different structures: sequence structure, which starts from S1, S2, Sn; branch, which may be if then else; loop, which can be classified into while loop, do while loop, for loop. Now let's go for the advantages of structured programming. Logical structures ensure clear flow of control. So the flow will be clear so that the data can be transmitted easily. Increases in productivity by allowing multiple programmers to work on different projects of the world. The programs are easier to understand since they can be read in sequence without the need of monitoring new lines, which is present in the blocks. The program structure is clear since the instructions are connected and related. It also reduces the testing effect. The monitoring of faults or errors of a program is provided due to the structure more visible so that the errors can be easily cleared and identified. It also reduces the maintenance cost of a program, and the program will be simplified based upon the requirements. Now let's discuss the various problems which is present in structured programming. There are three different problems: no restriction for accessing the data, relationship to the real world, new types of data. Object-oriented programming, which is called as OOP. O stands for object, O stands for oriented, and P stands for programming. Object-oriented programming best example is C++. Here it follows bottom-up approach. All the concept will be implemented from the bottom to the up. The bottom-up design is a way to construct software from small pieces of code in the whole system. Tools and libraries are developed first. Reusable parts are developed and implemented, and then the final product is built based upon object-oriented programming. Now, let's discuss the various features of OOP: objects, abstraction, encapsulation, polymorphism, inheritance, reusability. Let's see the difference between object-oriented programming and procedural programming. Object-oriented programming, the emphasis is on object or data. So we are working on data or objects in OOP. Here in procedural programming, we are working on functions. OOP, it follows bottom-up approach, whereas in POP, it follows top-down approach. In OOP, data hiding features prevents accidental change in the data. In procedural, data can be freely moved among the functions. In OOP, features are present such as encapsulation, polymorphism, inheritance. In procedural, there is no such features present. Now, let's discuss about the basic concepts of OOPs. First, classes. It's a way to bind the data and its associated functions together. So, a class consists of data and functions. Its significance is highlighted by the fact that John Stroudstrup initially gave the name C with classes. A class is a new way of creating and implementing a user-defined data type. Classes provide a method for packing together data of different types. It may be integer, float, or character. A class is a description of set of objects that share the same properties and behavior. Let's go for examples. Animal. So animal is a class. The objects are dog, cat, tiger, etc. Bird. Bird is a class. Objects are crow, parrot, peacock, etc. Subject is a class. Objects are computer science, maths, English, etc. Now, let's go for a class. A class consists of a class definition. A class definition starts with a keyword class followed by a class name, and the class body enclosed within a pair of braces. A class definition must be followed either by a semicolon or a list of object declarations. Let's go for a syntax. Class, class name, open the braces, access specifiers, private data and functions, close the braces, object name. Object. Objects are instances of a class that interact with each other at runtime. In OOPs, objects are declared at the end of a class definition or after the braces. They can be any type based on declaration. It shares two characteristics, state and behavior. Example, dogs have a state, name, color, breed, hungry, and behavior, barking, fetching, wagging tail, etc. Creating object or defining object of a class. The general syntax of defining object of a class is class name, object name, semicolon. Example, student S1 semicolon. Inheritance. Inheritance is a process of forming a new class from an existing class or a base class. The base class is also known as parent class or superclass. Derived class is also known as child class or subclass. Inheritance helps in reusability of code, thus reducing the overall size of a given program. Data abstraction. It represents the essential features without including the background details. Example, fan, bulb, etc. result in only concentrating but not on the mechanism which is involved in it. Data encapsulation. It means wrapping of data and associated function into a single unit called class. A class groups its members into three sections: public, private, protected, where private and protected members remains hidden from outside the world and thereby helps in implementing data hiding. Modularity. The act of partitioning a complex program into simpler fragments is called modularity. Each subprogram is called module, which reduces the complexity to some level. Now let's go for polymorphism. Poly means many and morph means form. So polymorphism means one name, multiple forms. It is the ability of a message or data to be processed in more than one form. C++ implements polymorphism through function overloading and operator overloading. Dynamic binding. It is also called late binding or runtime binding. It's a process of linking procedure call to a specific sequence code at runtime. It means the code to be executed for a specific procedure call is not known until the runtime. Dynamic binding is related with polymorphism and inheritance. Message passing is a form of communication between objects, inter-process communication and parallel computing. It may be synchronous or asynchronous. Simplicity. Because software objects model and real objects in the application domain, where the complexity of a program is reduced and the structure becomes clear and simple. Modularity. Each object forms a separate entity with internal workings that can be decoupled from other parts of a system. Object-oriented systems can be easily upgraded from small to large systems. Now let's go for how to improve the reliability and flexibility. Object-oriented system promises to be far from reliable than traditional system, primarily because new behaviors can be built from the existing objects. Because objects can be dynamically called and accessed, whereas new objects may be created at any time. The new objects may inherit data attributes from one or more objects. Behavior may be inherited from superclass and novel behavior and may be added without affecting the existing system. Reusability, which means eliminating the duplicate terms. Through inheritance, we can eliminate repeated terms or redundant terms and extend the use of classes. Repeating the same code in the program is avoided. The code can be called any number of times in a given program. Modifiability. It is easy and to make minor changes in the data representation or the procedures used in the object-oriented program. Changes within an object do not affect any other part of the program, which is provided by external behavior of the object. Maintainability. Since the design is modular, a part of the system can be updated in case of issues without a need to make a large-scale changes. Now let's go for the disadvantages of OOPS. Size. Object-oriented program are larger than other programs. Speed. Object-oriented program are slower than other program, partially because of their size. Other aspects of object-oriented program also demand more system resources, thus slows the speed. Effort. Object-oriented program require a lot of effort to create. Specifically, a great deal of planning goes into object-oriented program well before a single piece of code is overwritten. In addition, because the programs are larger, it takes plenty of time to write a given task.